Hello everyone. Today I'm going to talk about space complexity and some basic stuff. Last time we talked about the time complexity, so let me explain again. Time complexity is basically about how much time a program needs in order to start working. For instance, when you code out a program and you have your program, there is a time it takes for your program to run. So I would say some time that takes for your program to start running. Just like the time complexity itself, space complexity is about how much space a program takes, and it's specifically about memory. In an algorithm, time is not the only thing that actually matters. For an algorithm to be efficient, it has to be fast and take up as small space as possible. Back in the days, when computers were gigantic, as you see in the picture here, and non-mobile, time and space complexity were very important because space was always limited and computation was very slow. This does not apply to our generation that much anymore because computers are super fast and they can take up immense amount of space nowadays. However, this still does not mean that the current computing power is at the maximum level. Our society is still developing more advanced technologies like quantum computing to solve bigger and unsolvable problems that the current technology is still not able to solve. So when we talk about the space complexity, we are really talking about both physical space and memory a program uses. Variables that you declare take up the space. If your function is recursive, it uses stack space. For some developers, they say recursion is much easier because a line of codes that they have to write is much shorter. And to those people, recursion is very logical. For me personally, I avoid recursion if possible because iterative coding is more readable and easier just for me. In the next video, I'm going to talk about dropping the constant and the non-dominant terms. And before we move on to the next video, let me talk briefly about recursion and the code on the screen. So I wrote this code in Swift, and it's a function. It gets the sum when you provide a number. So what it does is, if you provide 5, it adds up from 1 to 5 and returns that sum of the number. So here in the first line of the code, if n is less than or equal to 0, it returns 0. This means that simply when it hits 0, it will return 0 and stop the recursion. Next line is where the recursion actually happens. Return n plus sum, and then parenthesis. In the parameter there, we give n minus 1. So if n is 5, now we're giving 4. And this will continue until n is 0. And when n is 5, the sum is going to be, 5 plus 4 plus 3 plus 2 plus 1. That should be 9 plus 3, 12 plus 3, so 15. Thank you for watching the video today, and see you in the next video.